Good morning, ladies and gentlemen. Last section, section 2.5. Then we'll have a review, and then we're going to have a whole test over these three different forms of graphing between intercept form and standard form. And the easiest of them all is vertex form. When I'm in the form f of x equals a times x minus h quantity squared plus k, where a, h, and k will all be numbers, okay? If you pause it and look for the pattern before I give it to you, you're going to need your Desmos up here, okay? And when we're graphing given vertex form today, like I said. So why don't you hit pause here really quick and do these two warm-up problems, graphing from intercept form and standard form, and from there, come back and see if you did them right. Okay, I'm back. When I'm looking at intercept form, or factored form we call it, I can see x plus 3 equals 0, so x equals negative 3, so I have an x-intercept of negative 3 comma 0. So I'm going to put that one there. And then I'm going to take my other factor, x minus 5 equals 0, so x equals 5, and I have another one at 5 comma 0, so I can plot that. Now, I know smack dab between those two is going to be my axis of symmetry. So if I take that intercept plus that intercept and divide them by 2, this is going to be my axis of symmetry of 2 over 2, which is 1. I know x equals 1 is my axis of symmetry. Okay, then I'm going to graph my axis of symmetry. I'm going to put arrows actually technically on both sides. Like I said, I always like my axis of symmetry red. And we said it's at 1. Whoa. Not like that. Need this back. I'm going to put it at 1. There's my axis of symmetry. And the only point on that axis of symmetry is, of course, going to be my vertex. And to find my vertex, what I need to do is I need to find what is f of 1. Well, that gives me 1/2 times 1 plus 3 is 4, times 1 minus 5 is negative 4. Negative 4 times 4 is negative 16, times 1/2 is negative 8. So my vertex is 1 comma negative 8. And I'm going to plot that up here at 1, negative 8. That's right here. And the next thing I'm going to do is I'm going to look back here and I'm going to say, my concavity, I can see this graph is going to be opening up because A is positive, concavity should be up. So I have just kind of confirmed that I hope I graphed my parabola correctly. When you're graphing from intercept form, technically speaking, you really only need 3 points, the 2 intercepts and the vertex. Sometimes, if the vertex is on the x-axis, you might need a couple more points. One you've been working on the last couple days here. Standard form. Well, first of all, I'm going to do this a little bit differently. This is the easiest thing to find. I can see this better be concave down. And the second thing I'm going to find here is my axis of symmetry at x equals the opposite of b divided by 2a, which is going to be opposite of 8 divided by 2 times negative 2, which is negative 8 over negative 4, which equals 2. So x equals 2 is my axis of symmetry. And what I'm going to do is I'm going to make it a little skinnier this time, and I'm going to dash it like I should have last time, but I really don't want to go back. And I'm going to go back and go 2. So there's my axis of symmetry. Nice little axis there. From there, I'm going to find out where is my vertex. So I need to find what is f of 2. Well, that's going to be negative 2 times 2 squared plus 8 times 2 plus 1. Well, this is 4 times negative 2 is negative 8 plus 16 plus 1. That gives me 8 plus 1 is 9. So my vertex is at 2 comma 9, which means my vertex is here. And then from there, because we learned our fast pattern, rather than plugging and chugging and making a big old fat table of values, what we're going to do, we don't want to do this, what we're going to do is we're going to do our old 1, 4, 9 times A is negative 2 times negative 2 times negative 2. So when I go over 1, I should be going down negative 2. So I'm going to go over 1 and reflect. Next one, I'm going to go over 2. I'm going to go down 8. I'm over 2, 2, 4, 6, 8. And reflect. And then, technically, if I can fit them, I'd be going down 18. So if I went over 3, I'm going on 2, 4, 6, 8, 10, 12, 14, 16, 18. And I can reflect that point across and make my cute little graph. And hopefully that's where we're at, okay? So from there, we're going to move right on to the next one. I'm going to pause and calibrate. I can see my calibration's off. Okay, I'm all calibrated. So we're looking at vertex form today, and there's a really nice, cool portion that goes through here. I'm ahead of this stupid thing. Right there is my vertex form, okay? Now, we're just going to say the impact of A remains consistent with the impact this value played when graphing from standard form or factored form. Remember, factored form, f of x equals A times x minus root 1, x minus root 2. That A, what it did is it determined what? It determined up and down, okay? So if A is positive, we know we're concave up, and if A is negative, we know we're concave down. Now, what that means is what you probably found out with your 149 pattern is that if the absolute value of A, basically that just means if A is a fraction bigger than 1, your graph is going to get skinny like option B we had in the warm-up, okay? And if A is a number between the absolute value of A, it doesn't matter if it's positive or negative, but basically if it's a fraction that is between 0 and 1, not a fraction like 5 over 4. That's greater than 1, okay? It's got to be less than 1. And then it gets wide like you can see A. A is much wider than B is. So the way I always remember this is I remember fractions less than 1 make them fat. Fractions make parabolas fat, okay? So now what we're going to do is we're going to do a little impact here, hunting here, and we're going to compare the H value. And when I'm looking at standard form, or vertex form, I'm only looking at A is always going to be 1 here. We have no K. What is H doing in my graph? Well, I went ahead and I graphed these 3 problems for you. And I'm going to cut. I didn't want to do that. I'm going to go down a little bit. And we're going to see, well, the parent function, f of x equals x squared, is right here. And then what happened when I subtracted 3 to the inside? What happened to my parabola? They're the exact same shape, fatness. One just moved a little bit. And what happens when I add 4 in there? Well, bottom line, this is vertex form. We're going to summarize how the H value affects the graph of f of x when I'm subtracting inside the function. And when I'm saying inside, it's because I'm subtracting something before I'm squaring it. I'm inside that x squared now. What that H value does is that H value shifts the graph horizontally opposite the sign. Check it out. There's nothing in here. This is like x plus 0 squared, so it's parent function right in the middle. Now I subtracted 3 in the inside, and it pushed every point 3 units to the right. I added 4 in the inside, it pushed every point 4 units to the left. It's kind of cool what that did. Now, we're going to see what happens when I do something outside of the function. And this is just the way I think of it. You don't have to write this down, but outside, see how I'm adding something on the outside of the square, not to the x. I'm adding outside of x. Well, what does happen here? Check it out. Well, here's my parent function again. Well, if I add 2, what happened to this blue one? Ooh, it pushed it up. If I subtract 4, what did it do? It pushed it down, okay? Pushed it down 4. Describe the changes in number 5. Changes in number 5? I forgot to describe that on the first one, but it shifted shifts down, or up, excuse me. I'm getting all flustered. Shouldn't be. It's pretty simple. Shifts up 2 units. Number 6, what happened? It shifts down 4 units. Okay? So it shifts down 4 units. And if I summarize what happens, what the k-value does, the k-value shifts the graph vertically, the same as the sign. What am I talking about, the same as the sign? If it's plus k, like it's plus k, that's the sign of positive, that's why it went up. If it's minus k, that k is negative, that's why it went down. Okay, so that's what I'm looking at. I'm just going to come back here because dingus myself here, I forgot to describe my changes in my number 2 function here, and what that did is it shifts right 3 units, and here it shifts left 4 units. Sorry, I knew you figured that out, but I gotta be thorough. And do I have anything else on this slide? I do not. So now I'm going to come to my next slide, and let's look at h and k together. So thinking about what the inside of the function did, it shifted it horizontally. Outside of the function shifted it vertically. Where do you think the vertex is on number 7 here? And if you're thinking it's at -3, 2, you're right, it is. It's at -3, 2. Why don't you fill in 8 and 9 here quick, see if you get your guesses right. So if you set number 8 is at 4, -5, you're right. And -4, -3, see how I'm taking the opposite of that, same as that. The opposite of that, same as that. Opposite, same, okay? Opposite, same. So can we summarize this? Hopefully we can. Well, technically they like to say the vertex is at HK. Now, I keep saying opposite of H because that's what the subtraction symbol really means, is it means opposite. And plus means same, technically in math. So don't just grab the 2 values there. You have to really think about it. The vertex is at the opposite of H and same as K. So you might want to think this, sometimes people like this, it's at -HK. If you think opposite of H, same exact thing as K. That's, some people like to think of it like that. Every math book will write it that way because of the opposite symbol in the function there. Now, do I have more here? I do not. I'm going to go to my next page. Now we're going to put it all together. We're almost done. Hey, I got this video necked down to a nice short one, and if you need to watch this little rascal again, then you just go on and you watch this little rascal again. Simple as that. Okay, now we're going to put it all together, like I said. Okay, putting it all together. We're going to find the vertex. After we find the vertex, Dan, when you found the vertex yesterday and you did the old 1, 4, 9 symmetry pattern, wasn't that awesome? If you would have been in the room, you'd have been, why didn't you teach us this years ago? Well, you weren't ready for it. So, and we're going to sketch the parabola. Where is my vertex here? It's at the opposite of H, same as K. So I can say right there, here's my vertex, -3, 6, okay? Now, where's my axis of symmetry? There it is, x equals -3. So I personally, I would graph my axis of symmetry, because I like to. It really helps me graph it. And then from there, I'm going to give it the old 1, 4, 9 times my a value. A is -1. So what does that mean? I'm going to go 1 to the right, down 1, reflect. 2 to the right, down 1, 2, 3, 4, and I'm going to reflect. I'm going to go right 1, 2, 3, and I'm going to go down 6, 7, 8, 9, and I'm going to reflect, and I'm going to graph to the best of my ability that parabola. Now, when I look at this parabola, what is the largest / smallest y value on the function? This guy has a largest value. And what is that value? Check it out. That top part, that is the vertex. The y value of the vertex is always going to be the largest or smallest value. And when I'm looking at this graph, because it's concave down, that is the highest point on the graph. Therefore, it is a maximum. Okay? So, why don't you do the next two? Why don't you pause, hit pause, do 11 and 12 here really quick and see if you did them right. Well, I'm back here. This is a really confusing one for some students. And all I'm going to do is see that +4 is outside, so that's going to be vertical. But if I wrote this, it's just a big waste of time. X plus 0, quantity squared, plus 4. This is equivalent to that. It just happens to be in vertex form. So I can see my vertex is at 0, 4. It's a confusing one. But notice there is no b term. And when there's no b term, I can rewrite it with that coefficient out with a 0 inside like that. I'm going to say 0, 4. And that means my axis of symmetry is x equals 0. And then from there, I'm going to give it the old 1, 4, 9 times a. A in this case is -2, -2, -2. So I get -4, -8, -18. Obviously, that -18 is not going to fit on there. So I'm going to go over 1, and I'm going to go down 2. Check it out. Reflect it. I'm putting my axis of symmetry on first because I like it. And then I'm going to go over 2, and I'm going to go down 4, 6, 8. Now notice, the absolute value of -2 is bigger than 1. And notice this parabola is getting skinnier. The bigger the a value, the bigger the absolute value, the a value, the skinnier the fraction is. Does this have a largest or smallest value? It's got a largest. What is the largest value? 4. And is it a maximum? Why, it is. The next one here, number 12. Don't get confused. There's a +0. It'd be a waste of time to write it. So my vertex is at -1, 0. And I can see x equals -1. The x variable of the vertex is always the axis of symmetry. You just got to grab that value, slap an x equals in front of it. You can do your -1, 0. You can graph your axis of symmetry. And as I'm looking here, okay, I'm going to do my 1, 4, 9. This is going to be concave up, but times a half, times a half, times a half. Well, that's a half. That's 2. That's what? 4 1/2 or 4.5 for the decimal freaks. So I'm going to run over, and I'm going to go over 1, up a half, and I'm going to reflect that half. Then I'm going to go over 2, and I'm only going up 2, because notice this is a half. I'm going to go over 3, 2, 4 1/2, and a half is less than 1. And notice this fraction made my parabola a lot fatter than the previous one. Notice this is going to be a smallest y value on here. The smallest y value, barring what my graph says because it's there, the smallest y value is 0, which means it will have a minimum on it. Okay, my calibration won't get quite on. That's why my dot is off. And we get to the last one. A word problem in vertex form. Check it out. It's kind of hard to see, but this is vertex form. Ax minus h squared plus k. You ever have one written in that form? It's vertex form. So The arch of that Millennium Bridge forms a parabolic or a parabola with an equation right there, negative 0.016 times x minus 52.5 squared plus 45, where x is the horizontal distance and in meters from the arch to the left, and y is the vertical distance in meters from the base of the arch. Well, I can see my vertex is at 52.5 comma 45, isn't it? So if I came over and I said 52.5, 45, there's my archway. Well, again, I'm concave down, but bridges go over things, so my bridge is going to go like that. Okay? And notice, across here, it's really not drawn to scale, but because this is my vertex, that's an axis of symmetry there, right? So to get from this point to this point is 52.5 meters. I think it's meters, isn't it? Is it meters? Yep, it's meters. Which means once I'm at the vertex, to get from there down here, this point from here to here is another 52.5 meters because of symmetry at the same point. So 52.5 times 2, because I got that distance twice, the whole distance is from there to there. What does that equal? Well, looks like it equals 105 meters wide. Okay? And that does it for vertex forms. Actually pretty slick and easy. Have a good day.